Okay, let me turn on my video. Yes,
Okay,
yes,
connect.
I'm back in.
Okay, hi.
안녕하세요.
예, 안녕하세요.
Okay, hopefully you enjoy the rest of the evening. How's the Christmas over there, Alex?
Oh, Merry Christmas. Yeah. I've been coding so much, I barely noticed it was Christmas, actually. I've been, going back and forth. It's the most hectic time of the year, and it's stressful, but gotta love the holiday season, right?
Yeah, hopefully you are not disturbed by disturbing you at this this period of Christmas.
No, it's okay. No,
Okay,
no,
man.
no, absolutely not.
Well, I was actually gone through the video just now. It was pretty much impressive of the project that you have been the mastermind behind it. I believe this will definitely be a project to look for in year 2026 onwards. Yeah.
It's an
Well,
ambitious project, and we're doing what we can. I'm very excited.
yeah, I'm going through the video. I saw that there is a lot of mentioning of computing power here and there. As many as 70% of those computing power done nothing. Can you elaborate more on that? What does it mean by those computing power sitting there doing nothing?
Yeah. Well, I'm sure you have a computer and it's sometimes off, right? So it's kind of like that. So instead of your computer that you paid for, maybe you bought a good graphics card, um, that's just sitting idle. And why not plug it into somewhere and actually use it to do some calculations, which that's what it's made for, and do some mining. So essentially, computers, even servers that are always on, they are just running, and they should be doing something. That's what I was thinking. So that's what we're trying to do.
Wow, a brilliant idea, huh? This is something very excited to me because a lot of people think that how is this computing power can actually make some money for like common people like you and me, some probably some we have an old computer sitting behind our garage doing nothing. I never thought of this can become a place where you can buy and sell of this computing power. Yeah. So you're talking about a marketplace where we can buy and sell of this thing. How do you
Exactly.
elaborate that?
Sorry?
How is this possible? Can we just buy and sell in those like Amazon
Well,
or
I
Shopee
mean,
like?
not really, right? Like the way it works today, is you can rent processing power, you can rent it by month or hour, all these types of things, but there's no real way to just do compute on demand. You say I want to calculate something. I don't want to worry about like having a server or installing Linux or doing something like this. I just want compute. I want it now. I want, I maybe I'm doing inference for AI or something like this, and I want it immediately, right? And on the other hand, there are people that have computers, and they don't know what to do with them. They're literally off when they're not using the compute. So we're trying to bring these two groups together pretty much, on like the highest level. Does that make
Yeah,
sense?
yeah, makes sense to me. I also try to recall those days when the early stage of the Bitcoin mining era, whereby we can use our common PC or desktop at home with the simple graphic card, then you can do mining. Yeah. Yeah, of course, we those days we call it the proof of work, POW. I can see that now we have a special term for it. We call it proof of compute. Yeah, this is something new compared
Yeah,
to the POW. Can you elaborate more about this proof of compute?
sure, sure. So when you're doing a remote computation, there's a couple problems, right?
Mm,
So first, like the first problem is, how do you know that the computer on the other side of the network actually computed what you wanted them to compute, right? So there's a whole task verification kind of layer that we had to build. And this uses cryptographic proof. So there's a mathematical way to find out who did what and when and where and how. And they use zero knowledge snarks, so it's a like circuits constructions we call them, and it's pretty complex how that works. I don't want to break it down right now. I think everybody here needs to get a math degree first, and then we can figure that out. But essentially, that's like the first layer that we make sure that we know who computed what and was the task completed correctly, right? Then there's a whole hardware kind of layer to this. So similar to how your phone works, there's something called a secure enclave on hardware devices. And this is so like, for example, you cannot easily clone your SIM card or something. Otherwise, it would be easy for me to just make multiple ones and then have, this kind of thing. So we use that kind of same technology to just make sure that we know who did it, right? Who did the task, which actual hardware, like physical device did the work, right? And then there's like a whole third layer where we kind of figure out what resources are available, what was actually used, how much more can a given device on the network do, and that kind of a thing. And so with those three layers, we kind of call that the CPC, right? Proof, and we call it the compute proof certificate.
Yeah.
And that's kind of how we measure how we can basically do remote compute.
Mm. Right. Awesome stuff that you have there that you mentioned just now. I believe that there are many of the layer one blockchain in the market like Ethereum, Solana. What makes you think that we should have another sole proprietor layer one blockchain so that it can actually works better in this manner?
It's actually a complicated question, but so first of all, the throughput, right? So the way that current blockchains work, um, they are used for transacting, usually financial transactions, and the economy is pretty big, and financial transactions are you need pretty high TPS to do just the financial aspect of things, but computation is so much bigger, right? It's you must compute many times, maybe for a single payment. And so the existing infrastructure just didn't cut it for us. We tried, we thought about it. Hey, we can just do this on something like Solana, but actually it doesn't work. And so we had to create a whole new kind of compute infrastructure in order to actually be able to handle the amount of load, the amount of transactions we need on a new blockchain. So we did this with something we call the quantum structure model. And what that allows us to do is that we have basically we can shard out the computation. And so we have multiple computers being able to work together to compute something. That's called sharding. And then we can also like parallelize things at that point, right? So let's say you have some kind of complex computation, and we can kind of chunk that up, send that out to the network, and then that's something that is very hard to do. Like this kind of balancing is very hard to do across a traditional blockchain because they're not built for this kind of a thing, right? Then something like Bitcoin, they use a POW, which is great. We also use POW, but we don't only use POW. We needed to do we needed this kind of the proof of POW, but we need the speed of POS and this consensus mechanism because we're doing the sharding, because we're kind of spreading out the computation really quickly and in parallel. So we use this kind of deep-in POS consensus mechanism that other changes don't have in this manner, right? And then the third thing is, of course, that if we have control over the chain, if we make it ourselves, we can really design the primitives that we need to do this kind of massive global scale computation. And so, if you're doing inference with AI, like and that's on a global scale. You just can't take an off-the-shelf blockchain like Solana and just put something on top, and that, we definitely tried that, but it's just not possible. So we needed to make our own. That's kind of it.
Yeah, of
I hope
course.
that makes sense. I'm trying to
Yes, it
be
makes sense.
not too deeply technical, right?
Yeah, we could understand your explanation. Of course, to do something one of its kind in this world, I don't see such project elsewhere. And that's why you need a specific, layer one blockchain to actually accommodate the demand, of course, the requirement of this so-called layer one blockchain. Whereby I also know that you can actually use a modular level, just something like Lego. People can just plug and play. You want this portion, just plug it in. This makes things so convenient. So who will be those your target audience when we design such a powerful piece of blockchain? Who will be those target audience?
Right. So we're primarily targeting people that need lots of compute. So the first thing is pretty obviously AI, AI research labs, people that do a lot of inference, these kinds of things. And especially those that don't want to just give all their data to OpenAI and all these other, larger centralized and like AI inference companies, right? So if you're interested in, keeping your data, having sovereignty over your data, and you do a lot of AI compute inference, then you're definitely one of our target segments. Another thing that might be interesting for that target segment specifically is if you're geographically distributed, right? So if you want to have the compute like close to where you are, you don't want to ship it off to interesting. Another, since we just have GPUs and compute, just a more traditional use case would be render, right? Any kind of 3D graphics. The video we just saw for our intro, like that needs to be rendered and created, especially when you're using, you're editing, you have an iterative workflow, and you're using a lot of compute for that. So we actually had a use case where one studio produced a short film, and they used 400 distributed GPUs, and they were all over the world in 12 different countries, and they kind of came together to make a single video. And another use case for compute, anything where you just need massive compute, any kind of scientific research, any kind of, protein folding, anything that just requires a bunch of machines, like a lot of
Oh,
power. That's something that would probably be interesting too as well.
yeah. Of course, this such project with such a scale and a size, are you afraid that those like the key players in the market like AWS, are they going to like you have a brilliant idea? I want to copy what you do. How do you prevent, let's say, another
Yeah.
competitor to come in and try to emulate and copy what Bob public chain is trying to do?
It's a valid concern, especially because today, right now, you would probably want to go to a AWS or Google because they're the only people that have this kind of compute available right now. And so, we're kind of in competition with them in a way. I guess that makes sense to think about this way. But I think we're in a very unique kind of position because, first of all, they are the victims of their own success. Like I just said, AWS or Google or Microsoft, they don't want to be decentralized, right? They're going to stay centralized, and that's their business model. That's how they work, and we're a truly decentralized kind of marketplace. So that's like I'm a true believer in decentralization. I think that's a great thing, and I think in this case specifically for the compute, being able to control where that compute is, not trusting a single vendor, and not being reliant on such a big name is actually good for risk. I think right. So that's one way. The other side is that a lot of these larger cloud providers, they have so much hardware and they have so much compute available, but they never can max out 100% of their hardware, right? Because then they wouldn't be able to onboard new customers. So they're sitting there with a bunch of extra compute as well. So, we're talking to them and trying to get them to use their compute on our decentralized network as well. So actually, they are potentially our customers as well, not only like our competitors.
Yeah, I agree with that. There are many big and huge data centers sitting everywhere, especially we're talking about they needs a lot of electricity, number one. Two, they need a lot of water to actually cool down the whole. I mean, you need to have a very cool environment for that data center. And I can see that these are very centralized, but your model actually decentralized, even to the small gadget like a smartphone, a desktop, maybe an iPad. It's pretty much fulfill the blockchain criteria of decentralization. They are everywhere. So you are a strong believer of the decentralization, and this also prove that with this concept, now everyone can actually mine, just like the what do you call Asia tagline. Now everyone can fly. Now everyone can do mining with just a small gadget that is sitting in your house. You can use it for mining. So of course, we're talking about gadget like mobile phones as compared to data center. How do you maintain the quality of service and also the low latency when compute might come from a smartphone probably sitting in Buenos Aires, Argentina, and compared to a data center in Singapore? Isn't it a fundamental tension between decentralization and the performance?
Well, in some aspects, maybe, but actually no. And the reason for this again is kind of the way that data centers are in a centralized place and decentralized is kind of more spread out. So, a lot of the times you don't need that kind of massive power of a centralized data center. If you really need a lot of compute, you're going to have to get everything in-house. But that's usually cost prohibitive. You don't want to just buy a bunch of hardware, stack it all up in your own house or in your office and start using it. Usually, these compute workloads are also not like regular or scheduled in a sense. So, you can kind of batch process them out and do these kinds of things. And so what's happening right now is that people are, there's marketplaces, centralized marketplaces on AWS, for example, that where the prices are cheaper during the nighttime or these kinds of things. And so that already shows that the market in general is ready for trying to find the cheapest compute at any moment. You don't need it right now, you can batch it, right? And so decentralized is perfect for this. So even if there is a little bit of latency issue, when especially when you need a lot at the same time, and all of a sudden some compute is going on smartphones, iPads, like you mentioned, and this kind of thing, they're not just all in clusters, then that might be a problem at peak times if you're doing like real-time inference or something like this. But most, and I'm talking about, more than 80% of the workload is not real time. It's batch processable. And that's why for the first time ever, we can also use like smartphones and smaller device. I have an iPhone 10 here and it works just fine. And it's an iPhone 10. It's an old device. I'm using it for testing. It works. And that's really great. So I understand there's this idea that, decentralization, it's kind of slower. It has a latency issue. But for what we're trying to do here, it just ends up not being true.
Yeah, I strongly believe you and your team will definitely iron out this small little issue and make sure this project will go for a big bang and boom in the market. Yeah. And we know
I hope so,
that,
yeah.
yeah, you also as a chief architect for CaryPact. So CaryPact serves as I would say, a catalyst, a booster for the whole BOHR public blockchain. How do you foresee that to move from an early adopters into a mainstream?
Well, We need a launch first. It's happening 2026, right? So that's step one for sure. Um, but after that, like I said, there are a lot of companies, especially like we just talked about AWS, and all these like larger ones, like that just have this extra compute. So even though we're making this kind of two-sided marketplace for compute, our society right now just needs more compute. Everyone's building data centers. Everybody's trying to get more compute. This is another option for people to use. It's going to be definitely cheaper than building your own data center. That's for sure, right? And then all these people that are building these data centers, they need to utilize as much as possible of this data center to be profitable as soon as possible.
Mm.
So by enabling them to sell their extra compute to us, or to like through us, I guess I should say, to end users, I feel like, I have to say I am also a little bit on the tech side, not so much on the marketing and growth side. But the way that I see it is that this is just needed, and when it's one of those cases where when we build it, when it's there, people are going to start using it. Just because if you look at servers are getting more expensive. It's one of the rare products in the world that are getting more expensive now, especially if you use GPU power. You could rent a server 2 years ago for a cheaper price than you can today. That doesn't make sense. We're creating new GPUs. We have factories producing them, but the demand is just so much higher than the supply. That's why Nvidia just went up so high, right? That's why their stock price went through the roof. So I don't really worry about this at all. I think the world needs what we're building, and just more compute is more better.
Yeah, I totally agree with that. I believe that from the audience that we have here this evening or this morning at different part of the world, they definitely will want to look at project that going to run for the long term, number one, because we have seen that those from the layer one, like Ethereum, they have started from 30 cents in 2015 and went all the way to 4,900, close to 16,000x. How do you see that this project, the layer one from Bo public blockchain, are you going to surpass those records set by previous successor like Ethereum?
Well, I mean, I think so. I mean, that's why I'm doing this and not doing Ethereum right now, right? I'm excited about this. Like I said, I think it's all about the compute. We found, if you want to get into it with AI, for example, right? We earlier on in the AI kind of bubble, we were talking about, oh, we need to help the AI learn chess, for example. And then we found out that the less we actually tell the AI to do, the more compute we just give it. Do it yourself, learn chess.
Looks like the signal went offline again. Never mind. We just have to wait for Alex to come back online. Right. Just to share with you, I actually went through the papers of this project, and it's actually has the characteristic of becoming a layer one blockchain with features such as the DEX, decentralized exchange, and it has the cross-chain bridge to actually work cohesively with all other blockchain. It also have a swap functionality, and of course, not forgetting the wallet, yeah, wallet functionality, and of course the explorer, whereby we can actually trace where's the data actually flows. Yep, I just admitted you, Alex.
Sorry about that. I guess I just dropped.
I thought
Zoom is not
Santa Claus is
decentralized.
handing you some present. You're going to collect it just now. Well, I just share with them the functionality, the basic infrastructure of this Bo public blockchain, which is the DEX, the Explorer, the wallet, the swap, and also the cross-chain bridge. Maybe you should continue from where we left just now.
Yeah, sorry. Can you repeat the question?
Yeah, we're talking about how 5 to 10 years from now, how is it going to be look like? compare to those earlier layer one blockchain like Ethereum? Are you going to surpass them in terms of how many thousand or X a kind of growth if we actually buys the token, native token of both, which is the BOT?
Right. So you're asking how we're going to grow.
How are we going to
Yeah.
beat them? Prove that you are more powerful because big players like AWS, Amazon, they can't be wrong by investing trillions of dollars into such big data center. And you
Well,
also the
we're going
similar
to beat them
direction
by
like
having
them.
the best investors, right? Right. To spin up some nodes.
Yep, correct. Let's thank you
Yeah.
for your answer. Maybe we can ask the
What?
audience here. Do you have any question for our CTO? It's not easy to grab him during Christmas. Maybe he'll give you some Christmas present. I don't know. You can raise your hand and the admin actually can just unmute you and you can throw your question. Uh, I believe only English, yeah? Or if you think you are not a native English speaker, you can just write in the group chat. Okay, I just look at the group chat. I have somebody say, I'm Zhang Kelu from Hangzhou, Zhejiang, China. Okay, we have an audience from China, beside Korea, beside Southeast Asia. How about our friend from Korea? 안녕하세요. Do you have any question for our CTO here? No? If you want to speak, you need to unmute yourself. Not to worry if you miss this time because I already, you type in Korean. That's the challenge. I don't know Korean language. See whether I have the what translation feature there. Nope. Okay. Not to worry. Yep. I don't want to take much of your time, Alex, because I know you're still in the Christmas year-end kind of mood. We definitely will hear from Alex again very soon as probably next Tuesday, Alex. Am I right to say that?
Yeah, let's do it. I'm excited. I want to share this more. So that sounds great.
Yeah, probably we'll see you again next week, and probably we will actually look at this layer one blockchain from a different angle. Yeah. Thank you very much, Alex, for your time. You can continue to
Thank you as well.
celebrate
Merry
your
Christmas.
Christmases. Before that, I would like to do some sharing with you that because my line just dropped just now, I have to recall the information that I have prepared earlier. It's basically to let you know that tomorrow we will have a talk on the project, which is CaryPact, yeah, CaryPact project, and we will dive into the bits and pieces of the project. There you go. I can actually pull out the slide now. Okay, let me share my slide. And basically, what was same time tomorrow, 9, yeah, 9 tomorrow, we will have a business opportunity meeting. And we have speakers from the academy going to speak about the project in detail. Yeah, make sure you stay tuned, get the link from people who invited you into tonight's or this morning Zoom session. And before I sign off, you can take a snapshot of this QR code on the project of BOHR and also CaryPact. We have the website and Twitter X, Linktree, Notion. You get all the information, the videos, the Telegram, and you can follow us too. And so that you won't miss any of those information and latest update from us. Yeah. Thank you very much, Alex. I'm Dr. Brian Lee, the host for CaryPact Academy. Signing off. You can gradually leave the room and I'll bring you a song to end all this talk. Bye bye.